The Astronomy 1010 class at Tennessee Tech University created a scale model solar system that fits on Tennessee Tech's campus, with a 13.5 centimeter diameter sun placed in Volpe Library. We'll start with Mercury at 36 million miles from the Sun.
Mercury is the first planet in our solar system and one of the closest planets to Earth. When designing a scale model solar system containing the planet Mercury, there are a few things that you need to keep in mind. Number 1. Mercury is tiny. No, seriously. Mercury is the smallest planet in our solar system. In fact, it's barely bigger than the size of the Earth's moon. Number 2. Mercury is the closest planet to the Sun. Mercury is only about 36 million miles away from the Sun. Keeping these things in mind, we need to calculate the size and distance of Mercury for our model. Using some extremely technical mathematical abilities, it can be determined that in a solar system model with the Sun measuring 13.5 centimeters in diameter, Mercury would measure about 0.05 centimeters. Again, this is extremely tiny, and finding an object with a diameter that small can prove to be extremely difficult. However, you can use Play-Doh to sculpt a ball with about the correct diameter. Then you can use the leftover Play-Doh to make a new friend. Using some more extremely technical mathematical abilities, the distance from our pseudo-sun to our model Mercury can be determined to be approximately 18 feet. Given that our sun is in the Volpe Library here on Tennessee Tech campus, right here next to the Audubon Pan, that would place Mercury approximately 18 feet from its location, which is just around where this corner is. An interesting fact about Mercury is that despite being the closest planet to the Sun in proximity, it is not the hottest. That title belongs to Venus thanks to its dense atmosphere. Mercury may not be the hottest planet or the largest planet, but I still think Mercury is out of this world.
Now we'll move on to Venus at 67 million miles from the Sun.
Hi there, let's take some time to talk about Venus, the second closest planet to the Sun. It was formed, along with a lot of the other celestial bodies in our solar system, about 4.6 billion years ago. Galileo Galilei in 1610 was able to see that Venus had phases similar to the Moon that supported the Copernican model of a heliocentric solar system.
In our model, Venus is a grain of sand about 1/10 of a centimeter in diameter and is about 34 feet from the Sun in the Volpe Library. Our home planet of Earth orbits the Sun at 93 million miles, or 1 astronomical unit.
The planet that is being represented is Earth, and it is being represented by the head of a sewing pin. This bead on the pin is roughly 0.12 centimeters in diameter. It is located inside the doors to the Volpe Library. The distance between the two objects is roughly 14.5 meters. Earth is very interesting because it is the only known planet that sustains life. This could be because of the distance between the Earth and the Sun that creates a perfect living environment.
The average orbital distance of our moon is 239,000 miles.
The diameter of our moon was 0.031 centimeters. If we were to place our moon to revolve around the other group's Earth, we would find it nearly just a foot or two inside of the library. Our fun fact about the moon is that it is actually 2,158 miles in diameter.
The last of the inner planets, Mars, orbits the Sun at a distance of 142 million miles.
Mars is 0.06 centimeters in diameter, and to represent Mars, we are using a tiny piece of aluminum foil that's been rolled up into a little ball. Its location on campus is on the back side of the library. And a fun fact about Mars is that Mars has a year of 687 days.
The dwarf planet Ceres orbits the Sun at an average distance of 257 million miles.
This poppy seed represents Ceres in our model of the solar system. Based on our calculations, Ceres should be around 0.0091 centimeters in diameter, and this poppy seed was the smallest representation we could find. It needs to be located approximately 37.4 meters away from the model Sun, and the best landmark was the tree to the right when exiting the front of the Volpe Library. An interesting fact about Ceres is that underneath its icy and rocky crust, there's an immense internal ocean of liquid water.
Ceres is a dwarf planet located within the asteroid belt, which is a distribution of asteroids that lie between the orbits of Mars and Jupiter. Even though in movies you see spaceships dodging asteroids, in fact, the asteroid belt is mostly empty with a mean distance of about 600,000 miles between asteroids, so you'd have to be a pretty bad pilot to hit one. Jupiter orbits the Sun at a distance of 484 million miles.
The object we're using to represent Jupiter is a marble, which is about 1.355 centimeters in diameter. This object should be approximately 75.474 meters away from the model sun in the library, so we chose the intersection between North Peachtree Avenue and University Drive as our general location for model Jupiter.
The orbits of Jupiter's Galilean moons range from 262,000 miles to 1.2 million miles. The Galilean moons are Jupiter's 4 largest moons and are Io, Europa, Ganymede, and Callisto.
This next picture is a picture of Io. Its scale diameter is 0.353 millimeters, and its scale distance from Jupiter is 4.09 centimeters. In 1979, with the help of the Voyager 1, a photograph was taken of a volcano erupting on the surface of Io, the first one ever seen anywhere other than Earth. This picture represents Europa. Europa's scale diameter is 0.303 millimeters, and its distance from Jupiter is 6.51 centimeters. Europa intrigues many scientists because it has the potential to be habituated. Europa's surface is mostly water and ice, and the icy crust is believed to cover a global water ocean. This next picture represents Ganymede to scale. Its diameter is 0.510 millimeters, and its distance from Jupiter to scale is 10.4 centimeters. Ganymede is the largest moon out of all of them in the solar system. It is even larger than the planet Mercury. Callisto to scale is 0.467 millimeters, and its distance from Jupiter to scale is 18.2 centimeters. Callisto's surface is extremely heavily cratered and ancient. This shows a record of events from early history of our solar system.
Saturn orbits the Sun at a distance of 927 million miles. We've almost reached 1 billion miles from our Sun in the Volpe Library.
In this project, Saturn is represented by a spring doorstopper head. Its long side is 1.13 centimeters in diameter, and if the Sun is in the Volpe Library, Saturn is about 450 feet away in Texas Botanic Garden, located between Johnston Hall and the Fine Arts Hall. Saturn is known for its rings, but many people did not know that its rings are only about 100 yards thick, which may not seem very small, but when compared to the planet's 40,000 mile radius, this is very small.
Saturn's largest moon, Titan, orbits Saturn at about 759,000 miles.
Our object that we used is a tiny piece of gypsum, which is a type of mineral that measures 0.0499 centimeters. This piece of gypsum is supposed to represent Saturn's moon Titan. An interesting fact about Titan is that it is larger than the planet Mercury and the second largest moon behind Jupiter's moon Ganymede.
On this scale, Titan would be about 11 centimeters from Saturn. Uranus orbits the Sun at a distance of 1.8 billion miles.
The object we chose to represent Uranus is the back of an earring. It is approximately 0.45 centimeters in diameter. Our object should be located at the Ascension statue by the plaza. An interesting fact about Uranus is that it rotates on its side, completely different than our planet.
The orbit of Uranus is about 1.78 billion miles from the Sun, and now we need to zoom out a little bit to see some of the other objects we're going to look at. In this zoomed out photo, all of the inner planets are within that innermost circle, and the other orbits shown are Jupiter, Saturn, and Uranus. The orbit of Neptune is 2.8 billion miles from the Sun.
If the Sun were 13.5 centimeters in diameter, then we can see that Neptune would be quite small comparatively. We were able to calculate in this case that Neptune would be approximately 4.4 millimeters, or 0.44 centimeters in diameter in such a scaled model of our solar system. As you can see from the photo on screen, this is quite small. In addition, we chose a notable location on campus to indicate how far Neptune would be from the Sun in this scaled model of the solar system. We determined that we would have to place our model planet approximately 1,431 feet from the Sun. If we are given that the Sun should be placed in the library, then Neptune could be placed in the Hooper-Eplin Center, which you may also know as the Hoop. Neptune is the windiest planet in the solar system, where wind speeds can reach over 1,200 miles per hour. This means that wind speeds on Neptune can reach approximately 5 times that of the most powerful winds on Earth.
Pluto orbits at an average distance of 3.7 billion miles.
Here we have a small dot on the index card representing Pluto. Its size would be 2% of a centimeter, considering the diameter of the Sun at the Volpe Library is 13.5 centimeters. After running the numbers, we found that it would be located here at the new fitness center on campus. Some interesting facts about Pluto include the fact that it is the largest of the dwarf planets and that it's made up of 1/3 water, so whenever it goes by the sun during its elliptical orbit, it gains an atmosphere composed mostly of nitrogen.
We now know Pluto as a dwarf planet that exists within the Kuiper Belt, which is an icy asteroid belt out beyond the orbit of Neptune. It extends 30 to 50 astronomical units from the Sun, and on our scale, that would be about 435 to 725 meters from the Sun in Volpe Library. For us, it ranges about from the distance of the southern edge of campus to about where Cookeville Regional Medical Center is. The New Horizons mission took photos of some Kuiper Belt objects, such as the one pictured here. Additionally, the Kuiper Belt is the source of some of our short-period comets, such as Halley's Comet, which you'll see next.
Halley's Comet is a geocentric, periodic comet with a period of 75 to 76 years. It was the first confirmed periodic comet and is named for Edmund Halley, the scientist and astronomer who discovered this fact. It has a highly eccentric orbit around the Sun and reaches aphelion at about 35 AU, or 3.25 billion miles. If our model sun is 13.5 centimeters in diameter and located in Volpe Library, then 1 AU becomes about 14.5 meters, and we can place our model near Ray Morris Hall. As for the scale size of the comet itself, it will be 1.06 microns in diameter. Remember, there are 1,000 microns in 1 millimeter, so Halley's Comet will be about 1,000 times smaller than this grain of salt, or about the size of a red blood cell.
Voyager 1 and 2 are robotic space probes that have traveled beyond the orbit of Pluto. These spacecraft are approximately 3 meters in diameter, and in this project scale, they would be on the atomic level, roughly the size of a covalent cesium atom, spanning 291 picometers. Now that they are in interstellar space, Voyager 1 and 2 are no longer on campus in our scale. Voyager 1 would be approximately 1.36 miles away at the 19th hole clubhouse, and Voyager 2 would be 1.13 miles away at Big Tony's Pizzeria. If you've kept track of these missions in the past, you may remember hearing about when Voyager 1 left the solar system on August 12, 2012, and Voyager 2 on November 5, 2018, just over 2 years ago.
Voyager 1 and 2 have made it pretty far, but there's something even further out.
The edge of our solar system isn't actually the edge of our solar system, as many would think. It is actually surrounded by a giant sphere called the Oort cloud. It stretches out beyond the Kuiper belt and around it. It's believed to be about 200 to 100,000 AU away, and it's composed of trillions of icy bodies floating around in space. These icy bodies range from a few kilometers to a few thousand kilometers in diameter. It was theorized in 1950 by Dutch astronomer Jan Oort, who hypothesized that the comets that people saw had to originate from somewhere. Well, he thought since the comets could come from any direction or angle, that their origin had to be a sphere.
It took Voyager 1 and 2 40 years to leave the orbit of Earth, which was just inside the doors of the Volpe Library on our scale, and reach Big Tony's Pizzeria and the 19th hole clubhouse, and that helps us put into perspective the vast distances involved in our solar system. I hope you've enjoyed this tour of our solar system that fits on Tennessee Tech's campus and that it's given you some perspective on where we fit in our solar system. Thanks to all the students in the Astronomy 1010 class from fall 2020 for all their hard work.